Good afternoon. I am very happy to introduce our next speaker. And I think I have been always fascinated by people who can combine and integrate so many experiences and expertise and be professional at that level. Giulio is an architect, urban planner, and has an expertise of 15 years at VELUX, am I correct? And has been teaching and disseminating topics of daylight in architecture, being a researcher, and I think we are really looking forward for this presentation. So I hope if I missed something very important in the biography, please, I hope you will explain that in your lecture.
No problem, thank you. So, hi everyone, and again, thank you for having me here. It's a real honor and pleasure to be in such a prestigious venue and in such good company. I've heard a lot of amazing lectures and speeches before, really inspiring and really meaningful for my job as well. Before introducing my work, I will do an experiment. I will try to involve you with some live polls and questions during my presentation. So please try to go to this site using this QR code that you can frame using your smartphone or tablet or whatever. I hope the connection is okay. And let's try if the tool works. You will not see the results on screen because it was kind of difficult to switch from the presentation to the website, but I will see them here and I will tell you what are the results. The question is, can you answer this question? And it's kind of tricky, so be careful what you answer because you could provoke a paradox here. So some of you are taking this joke pretty seriously, and I can see that there's a lot of questions already, of answers already. And fortunately, 91% of you guys can answer these questions. Just 8% cannot, but they have answered this question as well, so I don't really know how to interpret this. Anyway, the tool works, so I'm really glad to tell you that I will be able to do some live polls in about 15 minutes, okay? Now, so please stay connected, because I mean the platform will be the same. You won't need the QR code again, I hope, because otherwise I don't know how to do that. So keep connected again. So I am an architect myself. I graduated almost 20 years ago. No, more than 20 years ago. I mean, time passes really fast. In Rome, and after a few years doing something else, I was an urban planner for 3 years, and then I was a freelance for a few years, and then I started working with VELUX Italy in 2009. At the beginning as a technical consultant for 8 years, which means that I basically would go visit architects and engineers and technical assistants in their offices and working side by side with them and help them use the company products in a proper way, which is kind of obvious for a commercial company. But I also had this task to try to raise the issue of dealing with daylight in a proper way, which is kind of difficult, you know, in the real world out there. But it was a really interesting training period for my life, and it triggered an interesting research for me that is still ongoing, honestly. So I've been researching for more than 15 years about this complex relationship between the actual professional practice and an intentional and consequential use of daylight. This is not me, obviously, it's just an example, you know, to give you an idea of the hundreds or maybe thousands of architects that I met and projects that I have worked on side by side with them. And what was interesting is that there were a lot of opportunities that were overlooked every time. You know, no one seemed to have an actual structured methodology to deal with daylight. You know, it was really difficult. Everyone was really in love with daylight, with using natural light, and they would quote Le Corbusier or whatever. But then, when it came to actually designing architecture, either with residential applications or commercial or whatever, they didn't really know where to go and how to proceed. They could not even explain their work with regards with daylight. And specifically, they had no answer to a couple of questions that I actually asked them. And the first one was, how much light do you have in a space? Which is a seemingly simple question, right? But I'm still wondering how many architects could answer this question about the works that they're doing. And the other question was, what kind of light? Are you able to describe light as perceived from a specific perspective within the space that you're designing? And this is interesting because, again, almost no one of them could really answer these questions with an accurate vocabulary or describing or using accurate tools, you know. This triggers a lot of other questions, you know, why is that? For example, is it true that our external stakeholders, our clients, or you know, the building companies or public authorities, are they not asking us anything specific about that? But again, it triggered a pretty long and complex research. So I started, again, researching and studying and writing stuff and meeting people from a different stage. My role changed. I became a training specialist. I went all around the country doing lectures and workshops, and now they're mainly webinars. This is my main job. Again, trying to study and reflect with other architects about this possibility to have an actual methodology to drive the design process in an aware way when it comes to daylighting design. I also started writing articles on magazines and a couple of books, one of which is right here. And I will give one copy to one lucky participant today. And I ended up, there's 4 more, honestly, so we can probably give more. Anyway, I ended up building this apparently complex methodology. It's kind of a chart where some categories and tools and terms are put together. And this is divided into 2 fields, you know, the right one and the left one, and they reflect more or less the questions that I have asked before. You know, how much light in the right side? And it has to do with the performance and quantity of light that you can measure in different ways within a space. And the other one, the left side, is about composition and vision. How do you see light? What do you perceive? And it probably requires a slightly different language as well, which is definitely not scientific or analytic, but rather more metaphorical, and metaphoric use of the architectural language has already been mentioned today, so I'm glad that I'm in pretty good company. So we will start with the right side. We will probably focus more on the right side than on the left side, but this is what it is. And the main thing, especially in Italy, but not only in Italy, is that we're normally using this thing that is called the window-to-floor ratio, right? It's nothing more than the ratio between the size of the windows and of the openings and the size of the floor of the room that the window is intended to provide light to. Despite having a pretty good national regulation in Italy about daylight, you know, that dates back to the 70s and with more accurate parameters, but we're still using this same approach almost every time. And I found out that we're in pretty good company across Europe. I mean, in many countries, they are using the same kind of approach, which is really simple and practical, but not really accurate, honestly, and we will see how it is shortly. I don't know how it is here in Latvia. So here's a question for you. This is not a Slido. It's a live question. Raise your hand if you're using the window-to-floor ratio, some sort of window-to-floor ratio. Don't be shy. Just a bunch of you. So I'm guessing that all the rest of the participants, they are either not using anything to, let's say, quantify or size windows or quantify light, or you're using something more complex, such as static metrics or dynamic metrics. Is that correct? Anyone who's using dynamic metrics, for example? Maybe someone? What about the daylight factor? I knew it, yeah. Just a few of us, right? So that's a common problem, okay? And that's despite we're having a new European standard that, I don't know how many of you know, it's not mandatory in most of the countries in Europe, but it's still something that we should reflect on. I mean, there's many countries that are starting to think how to incorporate it into their national regulation, and it says that all the spaces where people spend at least 1 hour of their time, they should have at least 300 lux for half of the daylit hours, for half of the space, And at the same time, they should have at least 100 lux for, let's say, the rest of the space, 95% of the space, right? And then there's a kind of translation with another chart that allows us to use the daylight factor instead of the lux, and it's divided for all countries of the European Union, and specifically for Latvia. It allows us to have, to aim to have at least 2.2% daylight factor for 50% of the space, and 0.7% daylight factor for the rest of the space, right? So this is what we're dealing with at a cultural and research level across Europe. So this is where some of the terms start to appear within the chart. You know, this 50% something is also called the median of something. You know, the median of a set is the value above which or below which is 50% of the values. You know, it's a statistic methodology. So the median daylight factor would be 2.2 for 50% of the space. And this is where some of the words, some of the tools start to appear within this chart. So this is what we should do to be kind of in control of the process instead of just not being to answer questions when asked about the quantity of light that we have. So how would a normal space, like a model space, behave compared to all this? Well, this is an example. It's a simple room, it's a simple box with one window. This is size right now with the window-to-floor ratio of 1:8, which is the one that we have in use in Italy right now, which corresponds to a 12.5% window compared to the floor. And when it comes to the actual quantities, it would mean a 2.13 daylight factor, median daylight factor, which would not be compliant with the European standard. So be aware that if you're using 1:8, for example, of window-to-floor ratio, it could be not enough to comply with the European standard. It's just an example, you know, to understand the relationship between a very simple and practical approach, but not really accurate, and a slightly more accurate and scientific approach that it's really affordable for everyone. All these images were done using the VELUX Daylight Visualizer, which is one of the tools that are available for free online, and they are certified, so there's no alibi anymore not to measure light, if you know what I mean. And what's the problem here is that the window-to-floor ratio only relies on a couple of geometric variables, right? So this is the main message that I would like to deliver. Light depends on geometry, right? If you study and work with geometry, which is, by the way, you know, the vocabulary and the very alphabet that every architect has, if you do it in a correct way, in a proper way, and in an accurate way, you will deal with daylight in a proper way. So geometry and light, they are kind of really good companions. They follow parallel paths. And the window-to-floor ratio is just the relationship between two geometric variables that are the size of openings and the size of the floor of the space. But there's many there, right? And it's really interesting to understand how all these variables react to light while changed one at a time, right? There should be like the methodological approach for the lighting design. And I'm really surprised that there's nothing out there in terms of, you know, academic approach, for example, when it comes to light, you know, fragmenting the various ingredients that we have to understand what's the consequentiality of that in terms of light. So we will see some of them. We will see explicitly 3 of them using also live poles. Let's start with the first one, the size of internal surfaces. So we will compare the first example that I showed you, you know, that kind of model space, with another one where something has been changed, right? And the difference is that the ceiling is higher, 1 meter higher. Instead of being 260, it's 360 meters high. And how would this affect light? So do you think the daylight factor will be higher or lower than the first one? And here's when I will raise another question. Right, so if you're connected with Lido, you will see that there's another question, and it says, rank the rooms according to the daylight factor, highest to lowest. So if you think that the room B will be higher than A, therefore higher than 2.13, you should vote BA. Otherwise, if you think it's the opposite, you will have to rank A, B. Only 4 votes. Is it clear, the question, if you have any? Right, so I will tell you what's the result afterwards, obviously. So if you think that B will have a lower daylight factor than A, you have to rank A, B. So you have to rank them higher to lower. Right? Is it AB or BA? Right? 22 votes. Some of you are understanding. 30 votes, OK. They're pretty much at the same level, B and A. I'm afraid I cannot show you this. It's really interesting. So we're not really aware. That's the meaning of this exercise, right? It's the normal architect, I mean, I don't want to offend anyone, but I mean, people who are actually working on normal stuff, we're not fully aware of the consequence of the choices that we make on geometry when it comes to light, the amount of light that they provide, unless it's related to the window-to-floor ratio. That's the main problem of my work. So you're actually saying that, well, half of you is saying that it is AB, and half that is BA. So there's no actual agreement on that. This is the result, right? So daylight will decrease. If you have a higher ceiling, you will have less light. And why is that? Well, you have the same primary source, same window, right? Same window-to-floor ratio, but you have a bigger box, meaning that you have more surface. And more surface means more reflections, but also it means that light will be absorbed more. So all the points that are in the internal part of the room that will be illuminated mostly by the reflections will have less light than before, right? That's the reason why with a higher ceiling, you will have less light. That's how the exercise works. Then another question for you guys. That will be the average daylight factor, which is slightly different from the median. The average is just, let's say, the quantity of light, whereas the median, again, is that value above which and below which is half of the room, which is a little more dependent from the distribution of light as well. But I always put both. So another example, what happens with the number of openings? How is the fragmentation of the openings affecting daylight? If I have 2 windows instead of just 1, with the same overall size, right, it's still 1:8 window-to-floor ratio. So instead of having 1 big window, we have 2 smaller windows. Again, let me start the poll. Again, you have to rank the rooms, AB or BA. Which one will have the highest median daylight factor? And again, this is interesting because we're always deciding how many windows will we have in a space, right? But are we fully aware of the consequence of that on the amount of light? Is that something that we think of, you know, when it comes to sizing and fragmenting openings? And we're just focusing on the quantities, right? But there's the other side of the chart that has to do with the perception of the space that we will see shortly. So in this case, B is winning, pretty much. There are 63 votes for many of you, and you are pretty much all of you, or most of you, are saying that B will have more light than A, which is correct, right? Again, this is interesting because we're relying on the median daylight factor, but if I asked you about the average daylight factor, that is the quantity of light that we have available in the space, that would be less than the first one. So in the second case, we have a little less light than in the first one, but better distributed. That's the reason why the median factor increases. We have to reflect on that. And we have to reflect on what it means to have a higher daylight factor in average, and what it means to have a more uniform and well-distributed space. And there's indicators that can help us doing that, right? But it all depends on the fact that we have to deal with the geometric variables in an aware way. And then there's the perceptual perspective for all this. I mean, we're not deciding to have 1 or 2 windows only because of the median daylight factor of the room, and that wouldn't be correct. You know, a good design stands in a good balance between 2 legs, you know, the performative part and also the perceptual part, right? A space has to have a meaning other than just a performance. So the first condition is what I call the minimum level distribution, where we just have 1 window. And what does it mean when it comes to the perception of the space? Well, it's all spaces that are more or less directed, right? We have a higher level of intensity closer to the window and a lower level of intensity far away from the window, and it's pretty simple in the visual field. We have a higher contrast, we have a lot and a lot less, right? That's the reason why we talk about a directed space, which could be a daylight goal, for example. So I'm not saying that it's not good or bad. It's just a matter of knowing what's the consequence of that. We have just one main character on stage. It's like a monologue, right? And it can be okay with smaller and simple spaces. It can be problematic with bigger spaces or more complex spaces when it comes to geometry or functionality. And that's because if you have more functioning in space and you just have one window, maybe very big, but just on one side, well, you will probably have a little, too little light on the other side. And you have to decide what function you will have to put close to the windows and which one you have to sacrifice putting it on the back, and therefore probably rely on artificial lighting, which doesn't really make sense when you have 40,000 lux outside, right? So it's a really important choice that you make, not only when it comes to the quantity of light, but also about its distribution, and also about the perception of the space that you have. Because in the second example, where we had two windows, that's what I call the second level distribution. And it's not only because the spaces are more balanced, and you can have more flexibility and more uniformity and more functions, but also because it can trigger more visual stimuli. Many architects are using the second level distribution because of compositional reasons. They want to have two characters on stage. They want to trigger an actual dialogue between characters, and they could be like two main characters or one main character and a sidekick or an antagonist, but it allows you to have a more complex approach when it comes to the visual needs. And that's the reason why we need two different possible approaches, one related to the vision and one related to the performance and functionality of the space. Right, and that's the reason why, again, these tools are on the methodological chart, where multidirectionality is like a sort of synthetic way to define the presence of more than one opening or more than one primary source, as I call it, to define like both a compositional and quantitative approach at the same time. That's the reason why it is right in the middle of the chart. So we were here, okay? And we've just seen the difference between these two spaces using this geometric variable. What about this one? This is the position of the openings. Can we deal with that when it comes to the quantity? Are we aware of what happens when the windows are placed in different positions? Do you know what's the consequence of that in terms of quantity? So let's go with another poll, and this is a little more difficult, so we'll give you a little more time, because you have to rank 5. Okay, so there's A, B, C, D, E, and while you vote, I can describe them. So the first one is the one that we already know, right? The second one, the window has been pushed towards one of the corners in what we call the grazing position, right? Third one, it's a vertical displacement pushed towards the ground. It's not grazing to the floor, it's like 20 centimeters higher, but still it's pushed downwards. Third case, it is pushed upwards until it reaches a grazing position towards the ceiling. And in the E scenario, the window is on the roof. It becomes a zenithal or zenith device, a zenith window. What do you think will happen in terms of quantities? And there's 20 votes. I know it's a little more difficult than before, right? It requires a little more time. But still, there's already something statistically relevant. Right now, the order would be E, D, A, B, C. E, D, A, B, C. But you still have a few seconds if you want to vote, but I don't think that percentage will change a lot. E, D, A, B, C. That is correct, right? And there's differences by a lot. That's what stands out. The position, for example, is one of the main choices that we make. The most influential variables that we have, much more than the size of the window sometimes. For example, we can see that putting a windows on a roof is something that provides a lot more light than on a vertical wall. And that's simply because that window will frame much more sky than the previous one. A vertical window, in the best case scenario, can frame half of the sky, right? And a horizontal window, in the best case scenario, can frame 100% of the sky. So it will provide at least twice the light as a vertical window of the same size. And the same goes for all the different possible inclinations of the roof, right? It will be intermediate values, let's say. And the other reason why is that the top part of the sky dome is brighter than the lower part, So if you frame that part, you will probably get more light than the amount that you would get from a vertical opening. So I'm not saying that one is better than the other one, but I'm just saying that every window, according to its position, for example, provides a different amount of light and a different level of distribution. So we should be able to use the one that is good for that specific situation. But there's something that a zenith light cannot do, a zenith window cannot do, just like, for example, providing a good view towards the outside, you know, a feeling of openness and of continuity with the landscape. That's the reason why zenith light is one of the main characters of the chart. It is right in the middle, right? Because it's not only something that affects the amount of light and its distribution, but also something that provides what I call the secondary source, so a light reflected and provided in the really center of the visual field, which is something more effective when it comes to finding the right balance visually. So let's focus for a bit on this specific condition that I call the grazing position, right? It is not the best position when it comes to quantities, obviously. As you can see, at least 3 of them would not comply with the European standard according to the Latvian threshold, right? And that's interesting, having the same window-to-flow ratio. This one specifically is not the best treatment for light if you have to choose what's the right position, right? But still, a lot of architects go for it because it works a lot visually. You know, grazing positions are the ones that provide a grazing light. Therefore, those amazing and dramatic and scenographic patches of direct light or solid light, as Campo Baeza would describe them in his book, you know, if we're talking about metaphorical use of the language as well, on the walls, you know, depicting those very good and amazing diagonal shapes, or maybe if it's in direct light, they would provide a smooth gradient on the wall that the windows are pushed towards. So grazing light, grazing position is something that is not really effective, but still is really beautiful when it comes to, again, vision and composition. So we should always find the right balance, and there's always a way out. For example, going with the second level distribution. If you have 2 windows, you won't have to choose, because you can have one window that does one thing well and the other one that does the other thing well, right? So there's no short blanket, as we say. That's what I was saying, you know, you can have a grazing position with a smooth grazing light, both indirect or direct, and also grazing windows have this capability of aligning the openings with the lines of the architecture. I mean, you can see the lines of the surfaces, of the volumes, and then the openings are perfectly ordered with them. So the grazing position is just like sort of self-explaining compositional strategy, and that's the reason why probably many architects are still using that. I warmly encourage people to keep doing that, right? As long as you're able to keep the quantities under control. That's the reason why we need to be well balanced on 2 legs. And the same applies to the roof windows, right? To the zenith light on the corners, or simply push towards some of the corners to have grazing positions. Honestly, a high percentage of the projects that we put our hands on in the consultancy departments, they have to do with the integration of zenith light with the compositional intentions. And many of them end up being windows in grazing position to provide this amazing grazing light. So this is the methodology. We've just been through some of the tools and the categories that it contains. I would just like to show you a quick example of the implementation of this possible methodology. It's not an amazing project that I will show. It's just, again, it's very simple consultancy that I worked on a couple of years back, but it has a sort of logic and rationality in it. And it's a school that I intercepted. They were about to build it in a very small town in the center of Italy, and they asked me to work on one of the classrooms specifically to make it a sort of model classroom where light would be perfect in sort of sense, to work as an example for other possible classrooms or other possible school buildings and institutes for the same municipality or other municipality. And that was the classroom that we have decided to work on. So if you take a look at the plan and the section of it and keep the geometry variables in mind, you can already see that there's a lot of things going on. So being able to interpret technical drawings, plans, and sections, and we've already mentioned how sections are relevant, probably more than plans, right? Because you can see here that the size of the section is relevant, the height of the ceiling, and we've already seen how high ceilings cannot be very beneficial for the amount of light. I mean, there's obviously a structural and compositional choice behind this kind of curved roof that we have, but still we have to be aware that it will provide probably less light than a lower flat roof, so we have to act in a different way. Also, there's another big problem here. We have two windows, but on the same side and pretty close to each other. So it's an actual minimum level distribution, so just one big opening, and it's kind of low compared to the height of the ceiling. So I already knew that there could be problems, although the window to floor ratio were perfectly calculated in this case. So you don't need to do a specific analysis right on the spot if you are aware of how the geometric variables work. But then I did it as well, because we had a threshold that we would like to comply with, and it was, at that time, it was a European standard 840 that set the bar at 5% average daylight factor, and in this case we had 0.63, and no one knew that, right? Because no one is doing any kind of analysis, and no one is taking care of the geometric variables. They all know that, I mean, both architects and public authorities, they all know that the window to floor ratio is what is needed, and as long as someone is able to comply with that, they seem to be okay. So what did we do? Well, I just imagined that opening up one more window on the roof would be a good choice, and that's when I realized that the daylight factor would raise by 2.5 times, just with one small window on the roof, and that's because of the power of Zenith light and Zenith devices. So that was the right path, and that's when we decided to use 4 of them until we reached 5.37 daylight factor on average, which is exactly above the threshold that we wanted. But be careful, because when the numbers check out, that's when you have to worry. That's when you have to start designing and thinking, what would happen in the space? Is that the right thing? What happens while managing that space? And I don't know how to make this video start. Oh, thank you. I don't know who you are, but thank you. This is what happens, right? And that is okay. This is a kind of time-lapse simulation that I do using a rendering tool. This is fine, and I like it. If it were my living room, I would like it a lot. It has this dynamicity of the solid lights, etc. But it's a small classroom in a very small town in Italy, so I would imagine that having those patches of direct light moving through the horizontal plane could be some sort of problematic, right? Ending up on people, on small children, and provoking some sort of hyperilluminance and too much contrast and visual discomfort, etc. So it's probably not the right strategy unless you want to rely on blinds, etc. That probably would be down all the time, right? Can you imagine someone putting down blinds and then opening up again every day according to the angle of the sun? That's not really possible unless you're relying, again, on domotic stuff, but this is not the case. So maybe better if we rely on daylighting design strategies that use geometry as a tool, and that's the reason why we did this. So pushing the window simply towards one of the corners, and specifically towards one of the internal partitions that were facing south. What happens is that, well, this is the strategy that I call the confinement of direct light on vertical planes. It's not an energy strategy, but it's a visual strategy. What happens is that direct light will not invade the horizontal plane. It will be stuck on the vertical surfaces with longer strips of intensity, which means less illuminance, because that's the same amount of light, but with more surface, right? It will be more scenographic, more dramatic, it will be interesting, it will be graphically design something on the walls, but not in the eyes of the observers or on the horizontal planes. And that's what we did, right? I know that the grazing position is not the best when it comes to numbers, and in fact, it would decrease by a bit, right? From 5.37 to 5.21, but it's fine as long as I'm above 5%, right? That's what I mean by balancing the amount and the performance. This is another simulation of what would happen if, and I think it's a video, is it? Right? Can anyone Yeah, thank you, Mr. Hand. Right, this would be the 21st of June, which is supposed to be the day where the sun is higher. And as you can see, there's just a small fraction of the horizontal plane that is invaded by light. As for the rest, light goes all the way to that internal partition, and then it's like in reverse sunset, right? Upwards and on the other side. Anyway, this is what we finally did. This is some pictures of the final building, the very day of the kickoff of the scholar year, with an amazing and passionate speech by the mayor and by the director of the school. And this is basically it. You know, again, it's not an amazing project to be published or with amazing aesthetic and compositional features, but it's just something to show you that you can drive through the design process using daylight, having daylight in mind, and knowing the consequentiality between the geometric variables and what happens inside, both in terms of quantity and of perception of the space. There's a book about that. This is it. And obviously, things are dealt with in a more, in a deeper way in that book, which is intended to be like a manual for students or for architects. Again, to have this consequentiality in mind, to be under control during this design process. And I would like to give one as a prize to someone here who can win this competition. So let me ask you one question, one final question on Slido. This is a room, 3 pictures from the same room, from a very amazing house. And I'm asking you, what do you think is the median daylight factor of this room? Now, I can help you, a little tip. It's a value between 2 and 8%. And please write it typing number, point, 2 digits after the decimal point, okay? So the one who gets closer will win 1 copy of the book. Interesting. There's many of them. Unfortunately, they are not ordered, so I will have to run through it carefully. Wow, there's one that is pretty close. And please remember the number that you have typed, because otherwise I don't know how to call you. They're all pretty close, honestly, and there's probably a couple of them that are the same, unfortunately, because Dimitris, we will have to give away probably 2 or 3 copies, okay? Too many, guys. Stop. Do you all want the book? Okay. Well, the book is also available on the VELUX brand shop, so if you want one, you can purchase one, or you can ask my very good friend and local representative, Dimitris, here. Raise your hand, Dimitris. He's the guy. Right, so the right answer was 6.98. Did anyone assert it? No, sorry. Were you close? I mean, there's a 679, 699. Wait, who's the 699 guy or girl? 699. Guys, it's here, I swear. Don't be shy. Is it you, Dimitris? Okay. 6.99. Who are you? No one is claiming the book. No way. So I will go to the second best. Are you sure? Okay. Let's see. 678, pretty close. 688, closer. Maybe you don't remember what you've written, right? I think 689. 689. Who's 689? It's you. Okay, you're the lucky winner. Okay. Game's over, time's over. I'm sorry for keeping you a few minutes more. Thank you again.
Amazing. Of course, with such a wonderful presentation, there is not even much to ask, I think. Yet, I would like still to ask maybe a question.
Yeah, sure.
Yeah, maybe it's a bit more cozy. You were saying that there are opportunities overlooked, and you are already 15 years with VELUX and with designing with daylight. And are there themes or technologies or questions that you are still thinking that are overlooked, and themes that you're currently working on as a researcher?
Wow, well, there's a lot of them, honestly. If you're a researcher, you know that there's something always stimulating in everyone's work, and every project has its potentials and opportunities, honestly. So again, working with the geometry is the actual trick. You know, if you know what's the consequence of the choices on the outer envelope, especially when it comes to the openings, where are they, how many are they, the fragmentation, the number, the size, the position, but also the presence of obstructions, overhangs, that's probably the main trick, you know, having this intentionality of using daylight and also having this consequentiality in mind. And then there's the accuracy, which is another feature of a good methodology, you know, knowing the right tool to use, the right decisions to make. Then there's some more, let's say, more intense research fields, and one of them has to do with energy, for example, which is another topic that we have kind of grazed today. And in my opinion, as a daylight expert, it is related to the difference between the sun and the sky. So being able to differentiate light coming from the sky and light coming from the sun is crucial. Because one would be steady, for example, the sky is always there. So if a point within a space sees the sky, it will see it every time, all day long, right? Whereas if a point sees the sun, it will probably see it just in a certain moment of the day or of the year. So dynamicity instead of staticity. And then the light coming from the sky is normally something that you don't have to be afraid of, right? So being able to optimize the view of the sky and being able to control the light coming from the sun is probably one of the best thing that you can do. And thinking of obstructions as something that can be manipulated and changed is one of my personal challenges, you know, imagining that something that stands between a window and the sun can be pushed really far away, you know, like a kite or like a drone or something that can move according to the sun, that would make windows able to see the sky, to keep seeing the visible sky, but still be protected by the sun. So there's many challenges. I mean, I don't want to delve too much into that.
And lastly, what do you think you could give us as a case study where the user experience and the architect's or designer's intention of space and light is where you say, yeah, this is something to study and to look as an example?
Wow, you mean a reference?
Yeah.
It's really difficult, really difficult.
I know.
Zverev has been mentioned, for example, Louis Kahn has been mentioned. They are two of the sacred monsters for everyone who's designing daylight, and especially with what I call the gaseous light. You know, that, again, this metaphorical use of the language. If there's a solid light, as Campo Beta said, which means the direct light hitting a surface before your eyes, why not thinking of a gaseous light as light that enters somewhere and then spreads and tends to occupy all the space with a sort of uniformity and homogeneity, and that's what in museums, for example, you should have, right? And that we have heard a lot of amazing things about that. So Zverev, the pavilion of Nordic countries in Venice, is one of them. But talking about modern architects, I really love Vector Architects, for example. It's a Chinese firm and they're working with light in an amazing way. But there's also, I can mention Benedetta Tagliabue. She's an Italian architect, but she's based in Spain. And she's worked a lot with Enric Miralles. I mean, light is everywhere, and what's amazing is that there's potential for every kind of expression. What I'm focusing on is on what's behind that, you know, the basic language, the basic grammar of what happens if, right? And I think that's it, because otherwise I can mention a lot.
Yes, thank you so much for a fantastic presentation.
No problem, thank you. Thank you. By the way, sorry, there's also a liquid light, and if you're interested in the liquid light, it's in the book.